Welcome to Tectonic Nights channel. Here's day 9 of solving easy LeetCode problems in Python. Today's problem is given an array nums of length n and an integer target. The task is to find the number of pairs I, j such that nums of I plus nums of j is less than target. In the brute force approach, we check all pairs I, j and see if their sum is less than the target. We first define the length of the array, then we initialize a variable count to keep track of the number of valid pairs. Now we use two nested loops. The outer loop iterates over each element in the array from 0th index. The inner loop iterates over each element starting from I plus 1. For each pair I, j, if nums of I plus nums of j is less than target, we increment the count. Finally, count variable is returned. The time complexity of this approach is O of n square because we are using two nested loops to check all possible pairs. We can optimize the solution to O of n log n using binary search. The key idea here is that for each element nums of I in the array, we need to find the first index j that is invalid, meaning nums of I plus nums of j is greater than or equal to target. Consider the sorted array and target 2. Here nums of 0 is minus 1. We want to find the first index j where nums of 0 plus nums of j is greater than or equal to 2. At j equal to 1, the element is minus 1. Minus 1 plus 1 is valid as it's less than 2. Next j equal to 2. Here minus 1 plus 1 again, it's less than 2, hence it's valid. Next is j equal to 3. Here minus 1 plus 2 is less than 2, again valid. Now when j equal to 4, minus 1 plus 3, it's invalid as it's greater than or equal to 2. So the last valid index is 3 and the valid pairs are 0, 1, 0, 2 and 0, 3, giving 3 valid pairs for I equal to 0. To find the count of valid pairs, we simply need to determine the last valid index and then subtract the current index from it. Let's now try the binary search algorithm for this example sorted array. We want to find the first invalid index or the last valid index when the number is minus 1, which is nums of 0. Initially, the left pointer is at index 1 and the right pointer is at index 4. We calculate the mid, which is 2, the sum of selected number, nums of 0, which is minus 1, and nums of mid is less than the target, so this is a valid index. Next, we move the left pointer to search for an invalid index. The new position of left pointer is mid plus 1, which is 3, while the right pointer remains at the same index 4. We recalculate the mid, which is now 3. Again, the sum of minus 1 and nums of mid is less than the target, so it is still valid. We continue updating the left pointer to mid plus 1. So now the left pointer is at index 4. At this point, both the left and right pointers are at index 4. We calculate the mid again, which is also 4. The sum of minus 1 and nums of mid is greater than or equal to the target. To ensure this is the first invalid index, we shift the right pointer to mid minus 1. Since the left pointer is now greater than the right pointer, we stop the search. The left pointer is at the first invalid index and the right pointer is at the last valid index. Now let's dive into the coding section. First, we sort the input array. We initialize count variable to 0. This will keep track of the total number of valid pairs. Now we define binary search function that will take 3 parameters: the current number in the array, left pointer and the right pointer. This function will return the rightmost or the last valid index. For each number in the array, we use the binary search function to get the last valid index. This gives the number of valid pairs where the current element can form a pair with the elements up to the last valid index. We add this count to the running total and finally return the count variable. Thanks for watching. If you enjoyed this video, give it a thumbs up and subscribe for more content. Stay tuned for more videos in this series. Let me know your thoughts in the comments below. See you next time.